Hello everyone, my name is Ouassim, and I head the TIC Lab, which is our research lab of the university in Rabat, International University of Rabat, specialized in computer science. And our main research focus is on AI and its applications. And today I'll present you some of our activities and some research projects that I'm involved on that are on the topic of AI applied to health. All right. So I'll just go very, very quickly on the main research areas of our lab. We have 4 research areas. One is on low resource AI, one on cybersecurity, one on cyber physical systems, and one on complex systems. And they are all basically different ways to use AI. The first one is really on the theoretical aspects on AI, how to reduce the complexity of AI algorithms. The second, we are more towards applying AI for cybersecurity. The third one, cyber physical system, is basically the interaction of AI with the physical world. And finally, the fourth one is, I would say, some applied maths on the topic of AI. And we have several application domains. One is on media mining, cybersecurity, health, smart city, and the environment. So this was just a brief presentation just to show you what we are doing in the lab. And in this presentation, I'll focus on the health application of our work. All right? And so this work is mainly done under the main focus of low resource AI. And you'll see why. Because actually, when you are doing AI for health, you have a set of requirements that you must follow from a technical perspective in order to be able to, I would say, use AI in the health sector. The first one, of course, is inclusivity, right? And this means that you have to ensure that your AI is applicable to the whole population and not exclude some parts of the population. And so it involves making sure that you don't have biases and things like that in your training data sets. The second one, which is very important, is data privacy. As you know, health data is very sensitive data. You cannot process it as you want. It has a lot of regulations around it. And so you have to ensure that when you use your AI, you use it in a way that respects the privacy of your patients. And so this also has, I would say, some implications from the technical point of view. Mostly the third box, which is edge processing. Basically, as much as possible, you should do your processing locally and not send anything through the internet. Okay? Most of the AI algorithms that we know today, for example, ChatGPT, they are accessible from the cloud. Okay? They are basically some web applications that run on data centers globally. And so anything you put there, you don't know where it goes, how it's processed and everything. And so you cannot use, I would say, this kind of technologies in the context of health. You have to make sure that as much as possible, you do your processing locally and you don't have anything that goes through the internet. And this has huge implications because currently in the technology landscape, we have a lot of computing resources in the cloud. Whenever you want to do something, you can go and rent some computing power in the cloud in some data centers. And so you can run very, very computationally demanding algorithms. And usually, in the current state of technology, you can create algorithms that are very performant, but they will need a lot of computing resources. Now, in the context of health, you want to keep this, I would say, performance, but at the same time, you want to run it locally. And as you know, locally, we don't have huge data centers. We are limited to, I would say, smaller computers, and hence the low resource AI part. Okay, how can you do these big AI algorithms, keep them as performant and as precise as they are currently, but at the same time make them use less computing power? Okay, And the second, I would say, technical challenge also is the explainability part. Basically, compared to, let's say, ChatGPT, let's say you use ChatGPT to generate an image, right? You say it's okay, you give it a prompt, give me an image of an astronaut, a dog astronaut in the moon. Okay, it will generate you an image. You will receive an image, but the issue is that it's very hard to know how ChatGPT did or the steps that it followed to generate this image. It's a black box, right? Now, imagine you use ChatGPT, you give it an image of, I don't know, a CT scan. You say it, can you tell me if there is a tumor here in this image? Maybe ChatGPT will tell you, yes, there is a tumor here, okay? Now the question will be, how did ChatGPT determine that there is a tumor here, okay? And this is very, very important in healthcare because you want to make sure that when a health decision is made, that you can explain it. To say, okay, ChatGPT went from this step to this step to this step to this step to tell you that you have a health condition, right? Because otherwise you can have medical errors that can be life-threatening. And the question is, can you trust an AI that is a black box blindly to tell you this is what you should do? This is the medical procedure, okay? So that's, again, why there is a technical requirement when you use AI for health, that whenever it gives you a certain decision, that you are able to explain the reasoning behind this decision, all right? And so these are the main, I would say, requirements that we follow when we use AI for healthcare. And that's why in our lab, we mostly focus on this low-resource AI technical, I would say, research area with a huge explainability part, okay? And so now I will present you some projects that I'm involved on in the lab that are in this low-resource AI for the healthcare sector. So here it's one collaboration that we have with the hospital in Rabat, the military hospital of Rabat. And here the need came from them, so they contacted us and they told us, okay, we have an issue currently with the bladder cancer. So how they do it currently is they have patients, they come, they put a little camera inside the bladder, and with the camera they look inside, and the physician basically detects the tumors and tells you, okay, you have a tumor here, here, and here. The problem is several times in the bladders you can have a lot of very small tumors that are spread out in the bladder at various stages of development. Some are really like, I would say, starting tumors. Some are bigger, like the one you see in the bottom. And usually it's not the same surgeon that does the, I would say this, we call it cystoscopy, the camera that they put in the bladder. It's not the same physician that does the detection and the one that does the surgery to remove the tumors, okay? And so what tends to happen is that when you go to surgery, they receive a report from basically the first physician that tells them, okay, you have several tumors here, here, and there. But they may end up missing like a very small tumor that was nascent, not very visible, okay? And so what they tend to do is that every 6 months you have to do again the same procedure to see if there is another tumor that appeared, okay? So what they wanted us to do is basically to have an AI that processes the video stream of the camera and in real time detects the tumors and creates a 3D map of the bladder that locates all the tumors that were detected. And so now instead of having just a textual report going to the surgery, you have a full 3D map of the bladder with the localization of all the tumors that were detected. And this helps usually in the, I would say, the follow-up surgeries that you have, okay? Because it reduces the number of times you have to redo the same procedure, because it kind of saves everything, right? So this is what we started doing. So the first part here, while there are some technical details, I won't go into too much details here, but basically we started this project with them. We are now in the middle of it, and the project has 3 main parts. The first part is the tumor detection. So we created an AI with several steps and what we call a special attention mechanism that is able to detect accurately where the tumor is, and is able to also tell you how it detected this tumor. So here you see it's highlighted the tumor in red on the right. We did a second mechanism also. It's called NBI generation. So here it's another tool that they use for cystoscopy, which is instead of using white light, they use green light, and the green light is able to highlight better some tumors. The problem is that you cannot see both of them together. So the physicians told us that they wanted to have both of them together. So what we do is we generate the second modality in real time from the first one and vice versa. But when you do this, you want to ensure the consistency between the two. Because the problem of AI is that it can hallucinate, it can imagine new things, and you don't want it to imagine, like, I don't know, a tumor where it doesn't exist, right? So that's where we added some mechanism to ensure that this doesn't happen, using this thing on the bottom that we call vessel attention. So it's a new thing that we invented that makes sure that all the features of the first image are preserved when going to the second image. And the last part that we are currently working on is on putting all this in a 3D map, okay? There is another project that we're working on currently in the lab. This is on the topic of management of respiratory diseases, and this has several modalities. Okay, it has several inputs to the app, as well as a link with physicians. And here, basically, it's for people who have, for example, asthma, to be able to manage their health condition in a way that reduces the very dangerous exacerbation or crisis that can happen sometime. And so it has some sensors using, for example, the smartwatch, some stethoscope, etc. There is also a smart inhaler that we developed to make sure that it is used correctly, because the physicians told us that most of the dangerous cases of asthma-related hospitalizations are due sometimes to the inhaler not used correctly, so the medication is not, I would say, absorbed correctly. We also have a link with the air quality nodes with the platform that we also developed, as well as a link to the doctor in case there is like something that is starting. You know, proactively you can refer them to a doctor to make sure they are treated in time. All right. So for this project, we also developed an AI method that is also able to make it low resource. So here, I don't know if you see the little blue thing here. Basically, you have the audio. We do a mathematical transformation to transform it to an image, which is the blue and green spectrogram, we call it there. And this thing basically has a lot of audio frequencies. And here our idea is to say, okay, there are some frequencies that are not useful for detection of, let's say, some crackles or wheezes, or basically some asthma-related sounds. And so we can remove them and focus only on the important frequencies. And it also helps in the explainability. Because then when you say, okay, you have this kind of I don't know, symptom that is starting, you can clearly say, okay, it's based on these frequencies. Okay, you have an auditable way to do it. And then we have, well, some technical details in the bottom where we combine different techniques to make it low resource. And this is able to run on a smartphone. Okay, so it's small enough that it's always running and can allow you to detect the first signs of like an asthma crisis. Okay. We also combine it, as I told you, with I would say some sensors to measure the air pollution, indoor and outdoor. For the outdoor, we can use some also I would say data coming from various sources of the government. But the problem is sometimes indoors, because as you know, some people you have to really put some air flowing in your room from time to time, because otherwise there are some indoor pollutants that accumulate, and this can also have harmful effects for asthma. And so here, to make sure that people are aware for this, we also developed indoor I would say pollution sensors that are able to tell the patients and warn them about the early signs of pollution. And it's all I would say integrated with this main platform that has these several modalities. All right. And the last piece of the puzzle in this asthma-related application is several sets of, I would say, chatbots, but with different targets. Okay. There is one that we called asthma FAQ. FAQ is like Q&A in French. Is asthma speech and asthma bot, and they have different levels of knowledge. Okay, for asthma FAQ, it's really for the people that have no, I would say, medical background at all. It could be parents of children. It could be even children themselves. So it needs to explain the topics in a very, very simple way and tell only what is exactly needed to ensure that you don't have bad cases of asthma. Then we have an intermediate one that is also speech-based. And this one, the two first ones, they support the Moroccan dialect, okay? Because there is also an issue of language. And as my colleague Ihsan told you before, usually the more technical medical terms are in English or French, but when you talk with the patients, you have to use a language that is more understandable to everyone. And so these two parts are able to do this. Okay. The last one is more, I would say, I don't want to say technical, but basically it's more, it goes more in depth, right? And this one is in French and English, okay? And here, this is, well, the technical diagram of how it works. But the important part is the part in the bottom that says that at some point we use Gemini to have our, language generation, but we don't use it by itself. We have on the bottom left, we make sure that everything that it says is based on facts, okay? And these facts, they are coming from a set of documents, images, and videos that we put in databases on the bottom to ensure that when it tells you something, it is able to tell you, okay, I tell you this because in this document, like, it is able to cite the sources of the fact that it's saying, right? And there is the part on the right where you have a little icon of a person speaking. This is to say that basically you are able to interact with it with speech, but there are a whole set of translation systems to make sure that even if you speak in Moroccan dialect, in Arabic or any other language, you are able to use the main part in the bottom is in English. So the interaction with Gemini is in English, but you have a part on the outside that allows you to translate, okay, and to support other languages while keeping the facts, okay? All right, and so that's all for me today. I hope I give you a little overview of what we do in the lab on the topic of AI applied to healthcare and the main challenges that we faced. Thank you.